Hello, this is Dr. Cassandra Quave. In this lecture I'll be covering the history of botanical medicine and healthcare. This is a lecture that belongs with the course taught at Emory University entitled Botanical Medicine and Health. The learning objectives for this lecture are for students to identify some of the earliest archaeological evidence of botanical medicine. They should be able to answer what are some of the earliest written records of botanical medicine and who were the authors. What are the major botanical drugs isolated in the 19th and 20th centuries, and what are some examples of important medicinal plants. Now, plants have been used literally for thousands and thousands of years as medicines. In fact, our earliest evidence of medicinal plant use dates back to prehistory. There is an archaeological site located in Iraq. It's known as the Shanandar Neanderthal Cave, and this site dates to somewhere between 60,000 to 80,000 years before present. The archaeological evidence in the cave is that of pollen samples, and these pollen samples also happen to be rich specifically in medicinal species that are still used today in traditional medical remedies of the region. These include yarrow, shown here on the left, also the scientific name being Achillea millefolium. We have cornflower, or the red poppy, Papaver somniferum, hollyhock, bachelor's button, ragwort, grape hyacinth, and woody horsetail. We also have ephedra here. Now, these species were presumably laid on the ground and formed a carpet on which the dead were laid. And however, there is some criticism of the evidence, and this is based on a lack of detailed descriptions of the pollen in the archaeobotanical literature. And there's evidence that ants can also hoard pollen in a similar context. However, this could represent one of the earliest examples of medicinal plants used and identified in an archaeological site. Other evidence includes that of the Austrian or Italian Iceman of the Alps of Utzal, and this dates back to 3300 BCE. This Iceman was found with two walnut-sized objects, which were then identified as birch polypore, which is a bracket fungus that's found in alpine and other kinds of cool environments. Now, the interesting thing about this particular species and the fact that this Iceman was carrying them is that this species contains very toxic natural products and is also a very strong and effective purgative. And other studies have also shown that it has antibiotic effects against mycobacteria and toxic effects on diverse microorganisms. Now, the Iceman happened to also harbor whipworm eggs in his gut, so he had a kind of gastrointestinal parasitic infection that the evidence seems to show that he was actually using this medicinal fungus to treat his condition. Now, some of our early written records of medicinal plant uses for medical practices date back to those of the Egyptian papyrus and also other Chinese treaties. So one of the most well-known of the Egyptian records is that of the Ebers papyrus, which dates to around 1550 BC. Now, the papyrus is called the Ebers papyrus because it was actually bought by George Ebers, who's a German Egyptologist, back in 1873. And this is a 110-page scroll, which is about 20 meters long and contains about 700 magical formulas and remedies. One great example is that of a remedy for asthma, which involves a mixture of herbs that are heated on a brick, and the asthmatic patient can then inhale the fumes to improve their ability to breathe. Now, in ancient Chinese medicine, there is a drug treatise of the Divine Countryman that dates back to around 200 BC, And this documents around 365 drugs, mostly of plant origin. However, the original book information no longer exists, but parts are found in later compilations and later Chinese texts or herbals. Now, there have been a lot of different Materia Medica and herbal texts that have come out of the Mediterranean that have been well preserved over time. One of the most important is that of the Greek scholar Pedinus Dioscorides. He is considered widely to be the father of Western medicine, and his works were quite extensive in his recordings of traditional remedies throughout the Mediterranean. Now, Dioscorides was actually employed as a physician that traveled with the Roman army during the time of Nero. This is around the years of 40 to 90 AD. And he recorded the different uses of the flora in that region throughout the Mediterranean. And in addition to the flora, he also recorded uses of the fauna, animals, and also mineral remedies throughout the Mediterranean. And there are multiple uses of more than 600 medicinal plants are described. Now, what we've found is that through time, different translations of his original text were made, and actually many of the later European herbals, such as this example here, this is a reproduction in Arabic, Spain from the 12th and 13th century that we see here. Many of these, of course, the translations were based on the original text, but also other later herbals common in Europe also heavily relied on Dioscorides' work. Now, you should be familiar with Hippocrates. Perhaps you've heard of the Hippocratic Oath, but Hippocrates of course also mentions the use of approximately 300 to 400 medicinal plants in a number of his different writings, and these documents date back to between 460 and 370 BC. Now, other Materia Medica include the famous Drugs by Li Shizhen that dates to the 16th century, and in this text there are close to 2,000 drugs documented with more than 11,000 recipes and formulations described in this text. There's another treatise on the manner of all cures from Jamu, which is a form of Indonesian traditional medicine that also has close to 2,000 different formula. Now, Avicenna, who is known as one of the great polymaths, he was a Persian, who's famous for writing the Canon of Medicine. The Canon of Medicine is, of course, one of the most influential medicinal works, and it remains so, being used in medical schools for more than 500 years. And what's interesting is that he heavily relied on Dioscorides' works and recordings of herbal remedies, which were then incorporated into his text almost 1,000 years later in 1020 AD. Now, here's an example, here's a table of examples of different European herbals from the 15th and 16th century. You can see, of course, there are many different ones. Again, oftentimes these relied heavily on the works of Dioscorides. Now, here you can see that many of the medical traditions that we consider to be ancient actually persist today worldwide in both indigenous groups and in popular culture. And some of these you may be familiar with, such as Ayurveda, which is practiced widely in India, Unani medicine, also in India, but it has, of course, Greek origins, Jamu medicine in Indonesia, Kampo, which is a Japanese traditional medicine, which is in many ways somewhat similar to traditional Chinese medicine. You have ancient Egyptian medicine, TCM, shamanism, and curanderism, which is practiced, curanderism in particular is practiced throughout Central and South America. You have Native American traditions of the U.S. and Canada, and also African traditional medicine. The point here is that traditional medicine can be found in just about every region of the globe where humans live. Now, the state of phytochemistry in the 19th and 20th centuries, we moved towards this ability to actually isolate and identify some of the active constituents in these medicinal plants that had been used literally for millennia. Some examples of pure chemical entities that were successfully isolated include those of morphine. For example, morphine comes from the opium poppy, or Papaver somniferum, belonging to the family Papaveraceae. Now, morphine was identified originally in 1804, and it was chemically characterized as an alkaloid, of course, including an alkaloid is defined as a compound containing a cyclic nitrogen. And its full structural identification was not completed until 1923. Quinine, coming from many different cinchona species, was isolated in the 1820, and the structure was actually elucidated in the 1880s. Quinine was one of the most important medicinal plants, and really changed the course of history in many ways, and we'll get more into this in future lectures. Salicin is one of the early sources of what is now known as aspirin. It was isolated from willow bark in Germany, and then salicylic acid was derived in 1838, and later the acetylsalicylic acid was made in 1899. And again, this is another story that we'll get into more later when we discuss anti-inflammatory plants and plants with effects on the nervous system. Other examples of important compounds coming from plants is that of atropine, coming from Atropa belladonna, and that was isolated in the 1830s. Caffeine, coming from Coffea arabica, or the coffee shrub, isolated in the 1820s, and the structure actually elucidated in the 1880s. Conine, coming from hemlock, or Conium maculatum, which was a highly poisonous constituent, and it was isolated in 1826. It was actually the first alkaloid to have its structure isolated in 1870. Emmetine, coming from ipecac. If any of you have ever had ipecac syrup, this is something that helps to induce vomiting. It was isolated in 1817 and characterized in the 1940s. Strychnine was isolated in 1817. And tubocurarine, coming from Chronodendron tomentosum, which is the source of arrow poison and also an important medicine used in surgical anesthesia, as it causes muscular paralysis. This is a very complex alkaloid that was isolated in the 1940s. Now, there are many different important botanically derived drugs that we still commonly use today in our day-to-day kind of Western medical practices. And these include things like aspirin. Of course, the original salicin was coming from willow and also from meadowsweet. Our different opiate painkillers, including codeine, morphine, and dextromethorphan. We have important medicinals coming from the coca. A lot of people give coca and cocaine in particular a kind of a bad rap because of its illegal use in the illicit drug trade, but actually the coca shrub is an incredibly important medicinal plant, as it's the source for things like novocaine and lidocaine and these other topical anesthetics. Quinine, coming from cinchona trees, used in the treatment of malaria. You have sweet anise, which is the source of things like the artemisinin and its derivatives, which are important for the treatment of malaria. Foxglove, which is important in today's treatment of congestive heart failure. Ephedra, which is the source of ephedrine and pseudoephedrine, used in over-the-counter remedies for nasal congestion, atropine used in ocular procedures, and so on and so on. So still today, we have really incorporated a lot of these ancient botanical remedies into our modern therapy by isolating specific single compounds. But as we'll learn later in class, it's not always so simple to isolate a single active constituent, because in many cases the activity of these botanical therapies may be due to the synergistic action of multiple compounds. So it doesn't quite always fit that well with our current view of drug development and drug discovery, which relies on the isolation and study of single compound drugs. So in the 20th century, major things that were accomplished were that medicines were isolated and purified from plants, things including morphine, quinine, ephedrine. This made reproducibility of the remedies, of course, enhanced, and led to further medical applications of these worldwide. The structures of these compounds were determined, and this, of course, led to the synthesis of the drugs, and sometimes the compounds could be tweaked in a way in the lab to make them a little bit better than the original natural product. Now, unfortunately, the study of medicinal plants as a source of drugs fell in the late 20th century. This is because many thought that they'd basically found all that they were going to find, and that the approval processes were very lengthy and costly. In many cases, drug development and discovery has gone towards screening these large compound libraries composed of the products of combinatorial chemistry. However, this has been much less successful and less effective approach to screening for products than looking at natural products, because of the fact that natural products often have these very unique structures and chirality. And as we'll learn in following lectures, natural products are designed by nature to exert an effect on other biological targets. So it makes sense that things that are already engineered to hit specific targets could possibly be of more use in human medicine than something that's just kind of randomly put together in the lab. Now, we'll also learn more about the sale and use of herbal botanical products in the U.S., now sold as dietary supplements. These were allowed to go on sale without health claims by the DSHEA Act, and we'll cover that in the future. Now I want to kind of just introduce you to a few important medicinal plants. We're going to go into more depth with regards to the specific chemistry and mechanistic basis for their action in the future. But for now, I just wanted to kind of make you, introduce you to them so you can begin to become more familiar with these different plants. So the first I want to begin with is that of foxglove. Now, foxglove comes from the plant Digitalis purpurea. It has this very beautiful, characteristic bell-shaped flowers. Purpurea, of course, refers to its beautiful purple color. The use of foxglove in the treatment of a condition known as dropsy was documented by William Withering back in 1785, and this is William right here. Now, what's interesting is, of course, you should realize that, like many ethnobotanists today, this is not William Withering's IP, in the sense that this is something that he learned from talking to local healers. There was a woman in particular that he spoke with that taught him about her knowledge that she had learned from other healers about how to use foxglove to treat dropsy. Now, for those of you that aren't familiar with the term dropsy, it's basically an old name for what we know as today as congestive heart failure, in which the contractile strength of the heart becomes weaker and weaker, and the heart muscle is no longer able to adequately circulate the blood volume, and you end up getting quite a lot of edema and swelling and water in the tissues, basically. Now, this use that was documented in his account of foxglove and its medical uses is still used today. Digoxin and digitoxin were discovered, and they're used for the treatment of congestive heart failure. The Pacific yew is another great success story coming from a plant. It was first collected and tested in the 1960s, and at the time was not considered an ethnobotanical discovery. However, if you look at the literature, it is in fact a plant that has been used, and its use has been documented quite extensively within Native American and First Nations groups throughout the U.S. and Canada for different medicinal purposes. It took about 30 years from its initial discovery to become an approved drug. However, because it had such a low percent yield, that means that the percent of the drug that you could extract from the material was so low that the plant actually became endangered by its demand for the drug. It was once, again, traditionally used for tumors. Now, what they did in order to get around this problem of the actual source material being limited is they looked for other ways to produce the compound. And what they ended up doing is looking at other sister species within that same genus of Taxus, and found that the European yew was actually a good source and of a precursor to Taxol. And so what they do now is they can harvest the leaves of the European yew, which is of course more sustainable, and then extract the active precursor from the leaves, and then through some semi-synthetic steps convert that precursor into the Taxol, which is again today used in the treatment of certain types of cancer. Homolanthus nutans from Samoa is another example of a case of a success story. This is still a plant that's in the stages of development. It was used for the treatment of yellow fever by traditional healers in Samoa, and this use was documented by Dr. Paul Cox. And in collaboration with the NIH and their screens, it was found to have interesting activity against HIV. And the drug that was isolated is known as prostratin, and last that we've checked, it's nearing further clinical trials for HIV/AIDS patients. Turmeric is something that you've probably had before if you've ever had an Indian curry dish. This is the main ingredient in curry powder, and it comes from a rhizome in the ginger family, Zingiberaceae family. It's known as Curcuma longa. And some of the active and compounds found in turmeric include 2 curcumins, and they've been shown to have anti-inflammatory function. And there are multiple mechanisms of action involved here. These are highly active compounds, and we'll get into these more at a later date. Another great example of a success story of movement from traditional medicine to the pharmaceutical marketplace is that of Catharanthus roseus, also known as the Madagascar periwinkle. This plant was used traditionally in the treatment of diabetes, but there were some compounds that were isolated from the plant that were found to have interesting anti-cancer activity. These include vincristine, which is used for the treatment of childhood leukemia, and vinblastine, used in the treatment of Hodgkin's disease. And it's a beautiful little herb, as you can see here. Now, we've gone over all these different plants that have made it, again, from traditional medicine into the pharmaceutical marketplace, but I wanted to really drive home this key point, that some of our most important medicinals are really what we eat. Let thy food be thy medicine, and thy medicine be thy food. This was one of the key quotes dating back to to ancient medical history. And as you can see here in the picture, I've selected a few key things, such as these berries that contain important Anthocyanins, these are often incredibly good sources of antioxidants to help mitigate oxidative stress in the body. Things like broccoli and tomatoes, olive oil, certain grains. These are all incredibly important medicines and ways to help keep your body healthy on a day-to-day basis. Now, in summary, I want to state that, mankind has had a long and intricate relationship with plants as a source of medicine, and these ancient ethnomedical practices are actually still practiced today in many of our current traditional medical systems or ethnomedical and complementary alternative medical systems. Another take-home point is that we can still learn a lot. We can get a lot of clues for the development of modern medicines or modern pharmaceuticals by looking back to these ancient botanical practices. I think it's easy for some people to think that a lot of herbal medicine is actually just due to something like placebo effect. But the fact that specific plants, out of all the hundreds of thousands of plants on this earth, of plant species on this earth, that there are very specific plants that have been used for millennia for specific illnesses or specific purposes or symptoms, that in itself shows that there must be some underlying mechanistic basis for their activity. There must be some kind of functionality there. I think one of our problems in general is that we take an approach of looking for this single drug, single target idea of what a drug should be. Whereas with botanical medicines, you often have a very confusing mixture of compounds, or perhaps even a mixture of different plants being combined in a certain way, and thus even more compounds at play with different mechanisms of action. So I think as we continue work in this field, we'll learn more and more about what the actual mechanism of action is, and that will help us to get a better understanding of their efficacy and safety in human applications. Lastly, again, we've only just begun to identify plant compounds and understand their mechanistic basis, and there's still much more work to be done in this field. So that's all I have for this lecture. Thank you for listening, and stay tuned for more posts.